Today we will start new chapter, that is work energy and power. So little bit of concept of this chapter you got in class 9. So the first topic of this chapter is work. In the language of physics we say that work is the dot product of force and displacement, but in class 9 you only got that work is the product of force and displacement. Dot product, that part was not mentioned because in class 9 you did not know what is dot product. Okay, so if work is the dot product of force and displacement, mathematically we write it like this: F dot D. And we know that dot product is also called scalar product. The reason is that the result obtained from dot product is always a scalar quantity. So here in this case, work is the result obtained from dot product. So work must be a scalar quantity. So work is a scalar quantity. It has units also. The SI unit is joule. Joule means, actually, see, force, the unit of force is Newton, unit of displacement is meter. So Newton meter, it gives us joule. In short we write capital G. Okay, now see the conditions at which work done is 0. We know that just now we got it here, that W is equals to F dot D. If it is dot product, just like this, A dot B, in vector chapter we got how much it is, how we write AB cos of theta. So this theta is the angle between vector A and vector B. Similarly here what shall we write? FD cos of theta. Theta is the angle between force and displacement. Now see, if the value of theta is 180 degree, means if force is this way, displacement is this way, opposite, angle should be anti-parallel, and they are anti-parallel, so the angle is 180 degree. If it is so, the value of cos 180 is minus 1. That means the work done becomes minus FD, means negative. So work done is negative at theta is 180 degree. Just a note, you can note it down. Now see how this is possible, that force is applied this side, displacement is in opposite direction, or like displacement is this side, force is in opposite direction. How is that possible? Generally what we know, an object is there, if you apply force on the object this side, like you are pulling it, the object will get displaced this side only. But this case it arises in case of frictional force. Suppose we have this object on a table, maybe, or on a surface. This object is pulled this side with a force F. So in which direction the object is moving? This side, obviously. The displacement is also this side. But if someone asks you what is the work done by the frictional force in this case, since it is on a surface, on the surface there will be some frictional force. What is the direction of the frictional force? Back side, backward, right? This is the frictional force, suppose, and your displacement is this side. So this is the case where the frictional force and displacement are in opposite direction. That means angle is how much? 180. So work done by this frictional force will be negative because it is against the motion. But yes, work done by this force will be positive. I think it is clear. Okay. Now let us see the conditions at which work done is 0. So what we were saying, that F dot D, so we can write it FD cos theta. Now under 3 conditions work done can be 0. One condition, if force itself is 0. If force is 0, 0 into something will be 0. If displacement is 0, then also work done is 0. And the third case is very important case, if cos theta is 0. So cos theta is 0 means theta should be 90 degree. That means if force is this side, Displacement is this side, angle between force and displacement is 90 degree, then there will be no work done. This example, for this case, one example was given in class 9 if you remember. Okay, that time the justification was not given because the concept of dot product was not there. A person who is carrying the load on his head, I cannot draw the person, so just imagine this is the person. Okay, the person is carrying the load on his head and the person is moving this side. On which direction the person is applying the force? This side. In which direction the person is moving? This side. What is the angle between F and D? 90 degree. So in this case we say that though the person is carrying a heavy load, the person is not doing any work. Work done is 0. This type of cases where they are in class 9. A person carrying a load moving in a horizontal road, and we say that work done is 0. This is the reason, because force and displacement were in perpendicular direction. That's why. Okay. Then next one, work done by variable force. Suppose, okay, just a second. Suppose an object is moving from A to B. Okay, and the path of the body is divided into few parts. Suppose each part is having a length of dr, small length dr, and the force on the object is changing. The force on the object is changing. In the first part here, force applied is suppose F1. In the next part, another force, suppose F2. So in this way, force applied is not constant. It is variable force. Variable force. So in this case, how we will calculate the work done? Because work done at each and every part of the path will be different. In the first part, work done will be how much? If the force is F1, F1 dot dr. In the second part, F2 dot dr, F3 dot dr. So in that way, what we should do here? We should find out the work done for each part. Like the first part is W1, next part is W2, W3, and then we should add them, right? So if the path is a finite one, it's a small one suppose, in that case still there is a possibility that we can find out the individual work done for each fraction, and then we can add it. But if it is a long path, long distance, in that case it is difficult, right, to find out the force, to find out the work done for each individual part, and then to add them. So that is why addition is nothing but integration. Integration and summation are almost same thing. So what shall we do here? We will find out the work done for one small part like dr in this way, just like this, F dot dr. This is the work done for a small part. Then what we are doing, we are taking the summation, means integration. That means this integration is having a limit from A to B. That means we are starting from this end and we are reaching to the next end, means B. So this gives us the formula for work done if the force is a variable one. The force is not a constant throughout the path. From A to B, same force is not applied. Different forces applied the different part. So actually we are supposed to calculate the work done for each and every part, then we are supposed to add them. But instead of doing that, we can simplify the thing by taking integration, because integration is nothing but it is summation. So we can find out the work done for small fraction, and then we can integrate, or summation, we can take the sum of it within how much, within what limit, A to B. Okay, so this formula you remember. We will do sums related to this one for variable work done for variable force. So for this video this much. Next day we will discuss about this sum. Okay.